Okay, on the bench this evening, we got a classic radio from the late 60s. This is the Roberts R200, probably one of the most popular early transistor radios to come out of the Roberts line. Probably wasn't their first, well, it certainly wasn't their first transistor radio, but very popular, iconic design. And for those who've been following me for a number of years know that I've worked on one of these before. I've got a couple in my collection of old radios. This one was picked up this evening actually, and funny enough, most of my stuff, as you probably know, comes on from eBay, but this one actually came from Facebook, which I was rather surprised at. It's on their marketplace, and it was advertised by a local seller, this radio not working, for £5, so couldn't turn that down, and picked it up this evening, and it's physically in very nice condition. It's got one of the finials, or the brights as they call them, missing. That's probably not the end of the world. And there's I'm not sure, I think there's a bit of the R missing on the Roberts. I'm not sure, someone will probably be able to tell me that. It looks okay, but it just, I don't know, maybe it is okay. Someone tell me if the Roberts is correct or not. So overall condition is pretty good. You know, the dial's okay. The handle's in surprisingly nice condition, because these are one of the first things to rot away, and these handles then tend to be need to be replaced. The grille looks initially okay, but if you get it in certain light, you can see there are a few smallish dings in it. Nothing major, and I could probably push those out by removing the speaker. It's on a turntable, and for those who don't know, it's a long wave, medium wave only set. It's got this sort of like this classic styled dial on it. No tone controls, and then just the tuning here. Long wave on the bottom scale, medium wave on the top, and the office station annotations for the where all the channels used to be broadcast. Obviously, this is all obsolete now. So basically, it's in lovely condition. It's faded slightly. It's gone a little bit sort of. It's almost gone a bit brown. Now this would have been a sort of like a bright red colour initially. And also, I'm not entirely sure about this. This looks like an aftermarket or an afterthought. I've never come across one with one of these in it, but this does look like this was installed quite early on in the radio's life. And let me just open up the back to show you. Now here's the socket that's, I think, has been added, and this looks to me very sort of like 70s sort of soldering. This connector, this 3.5mm jack plug, certainly looks sort of circa 70s, 80s, 80s at the very latest. This looks like the old solid core telephone wire that you can buy, and for lacing, or for want of a better word, they just used tin copper wire and bodged into this the speaker terminal. So it's obviously an external speaker. That was the idea of this, and you can see it's connected into the external speaker, and it's not a bad job actually, really, but for a sort of like a home project. So I probably will actually remove that and put it back to how it was supposed to be, but I'll leave the jack plug in there, obviously, because you're going to have a hole gaping in the back of the radio otherwise. So it's pretty standard layout for a radio this age. It's got the plastic capacitors in. All these capacitors will be knackered. They'll be totally dried up. These will need to be replaced, and that'll be basically, I'm not even going to bother checking them. I know a lot of people say don't change capacitors if you absolutely need to. Yeah, trust me, these capacitors will be knackered. They won't work. The other problem is it does have AF 115, 116, 117s in them, whatever they are. So we're probably looking at a shield to a junction short along the line somewhere. Not always. It's not always the case. Funny enough, you can actually pick up a radio that's got these AF 117s in. You think, okay, this is not going to work, and it will work perfectly okay. And you can come back in 10 years' time, and it will work perfectly fine. But then a lot of the time, you know, you'll get one, and they've all got shorts on them. So it's a luck of the draw, really. It seems to be. I don't know if it's a batch change or something, or they've got wires to it towards the end. But you can't guarantee that all these radios are not going to work. They're easy enough to work on. They've got these little wedges that you actually just remove this wedge, and you remove the wedge on this side as well, and then the whole chassis drops out, which is quite a unique design really. And basically that wedge is held in by when the back panels close, it wedges in and it holds everything in place. Runs off of one PP9 battery, easy enough to get hold of still. Got the roller, I think it's a 16 ohm speaker. No RF amplifier, just a simple oscillator tuner and our aerial matching capacitor here. Very straightforward set. Probably, I think that's a 2-stage intermediate frequency. I think of a 455, can't remember exactly. This is our output stage here, output driver, biasing for the output stage, output transformers. I think that's a driver and output transformer to drive the speakers, because the early germanium transistors weren't really capable of driving an 8 ohm speaker or 16 ohm speaker. They had to be stepped up because they couldn't supply the current basically to drive the speakers. That's basically what it boils down to. Got the logo on the back here, the Roberts Radio Company Limited, very important. It's essential that any inquiry regarding this receiver's quote model and serial numbers. So it's a Roberts R200. The serial number is 142328. And so basically, I mean, the radio is pretty genuine, apart from possibly this modification that certainly looks like it was done at a very early stage. Can't be sure of that, but it's, you know, it's certainly not a recent change to this radio. So I think what we'll do this evening is we'll start with the very basics. We'll see if it powers up and see if it's got the classic AF117 shorted transistors on board, and then ascertain what we need to do to it. Obviously it needs all the caps replacing. That goes by the by really. I'm going to change the caps with some modern capacitors, and then hopefully if these transistors are okay, we're going to leave them. If they're not, we'll probably remove the shield connection. If that still doesn't work, we could try zapping them. Failing that, we could replace them with AF127s. I think I might have some of those, but somehow we'll try and get this radio up and working. It's too good to be used for spares and repair. You know, there's no battery corrosion or anything like that. So let's get this. Let's get some power on it, and then we'll have a crackle around with the switches to see if we get any life out of it. Right. It's got a supply connected to it, current limited supply, 9 volts, limited to about 100 milliamps. And so we can get any life out of this thing. So let's turn it on to long wave and turn the volume up. Totally dead. Okay, so that's a sure sign that there's something seriously wrong with it. I'm just checking if it's drawing any current. Yes, it is drawing current, but because it's totally dead, my first thought is, well, is this connection working? Is this bodged? Well, not bodged. This external speaker connection damaged, and it's not connecting the speakers. So what I need to do is connect a jack plug into here and work it a couple of times and see if we get any speaker connection. Failing that, what I would like to do is bypass that, if I think that's causing a problem. So let me find a jack plug. Just bear with me a minute. So I can find a 3.5mm jack plug in my box of bits. Nope, not at the moment. Okay, let me find a 3.5mm jack plug and see if we can work the switch a couple of times, see if that fixes the problem. Okay, found a 3.5mm jack. So what we're going to do is we're just going to have the volume turned up. Well, it's full volume actually. No, the speaker is connected. Ignore that. I can hear a click. Can you hear that click? Okay, so it's definitely working. It sounds like maybe the RF stage or the IF stage or the mixers isn't working, and that's more than likely going to be one of those capacitors faulty. So let's go around and give it the good old-fashioned tap on the AF117s. There we go. Any minute now it'll burst into life, he says confidently. You hear the crackling speaker? That one seems alright. Definitely got a crackle in the speaker. The current consumption is normal, so So this is looking at the moment like faulty transistors. Let's work the switches again. Okay, I can't hear anything, so let me just try and buzz around the amplifier stage so we can hear any buzz from the speaker. Not sure where I'm connecting, but one of these should be the... There we go, so the amplifier's working. You hear the mains buzz? So that's obviously the input to the audio amplifier. So we know the amplifier's working. Now the next step back from that is the detector and the IF stage. Now we can check the IF stage, and this is what a lot of people don't do. I never really understand that. It's a simple test to do. We're working our way back. We know the audio amplifier is working. Now I want to check to see if the IF amplifier is working. So what I'm doing at the moment behind your back is I'm adjusting my signal generator to around the IF frequency with an AM modulated signal in. And if we can hear anything, which we can't, we know the IF stage is working. So I'm sweeping now between 440 and 500 kilohertz, and I can't hear a thing. So we can ascertain now that we know the audio amplifier is working. We can sort of probably guess that the RF stage is working, though we don't know that, but we know that the IF stage is definitely not working. So it's one of these transistors here, and this is the IF amplifier. It's got a short on it, more or less guarantee that. So we can go around tapping these, but I think at the end of the day what it's going to involve is taking these transistors out of the board, zapping them or cutting the screen off, and then trying again to see if we get any signal with them. Now, as you know, these transistors are notoriously unreliable, and zapping them seems to work pretty well. I mean, I've done it on hacker radios and they've lasted sort of like, well, some of them are still going at 10-15 years afterwards, but I can't guarantee that's going to last forever. So what I'm going to do is I think we're going to have to strip this unit out, get these transistors out, do the zap test on them, or the zap trick on them, try and clear the tin whiskers away, and see if we can get the transistors to work again, because I would like to keep these transistors original if I can. If not, we're going to have to find something to replace them. Alright, that's the first transistor out, and you see someone's already been in here before to try and fix this. You see the screen lead's been cut, which is a fairly common modification to these to try and make them work again. But clearly this one is, the shorts are so bad inside now that it's obviously shorting out to the adjacent transistor junctions. Usually what happens is the screen shorts to either the base emitter or collector, but when it can get really bad they can short out to all the junctions together, and the screen can be actually isolated, because the can will just fill up with tin whiskers and just short the whole thing out. Might not be able to recover this transistor, but first thing I'm going to do is I'm going to put it on the transistor tester, or just do a diode check on it, which is perfectly acceptable, and we'll try it again. Now I think it's an AF1, yeah, AF117. You see it's been rubbed off, and you can see where I've been bashing it to try and get it to come to life again. But yeah, we'll check this transistor for sure on the transistor tester just to confirm it is this transistor that's failing, and we could try the zapping process. Failing that, the only other option is to fit another transistor in place, which I don't really want to do. I'd like to use this transistor if I can get it to work again. So let's pull out the transistor tester and see what it checks like. Okay, for testing a PNP transistor, which is most of these germanium transistors are, we need to find the base lead, and we connect that to the negative of the meter, and we should have a junction between, I'm sure that's the base, I need to check the pinouts, but I'm pretty sure it is. We should have a junction to here, which is not showing anything, and then another junction to here, which is not showing anything either. So either that's not the base or this transistor's faulty. Let's try and another lead. Now battery is showing low on the meter. Nothing there. Nothing there. Nothing there. I've got a junction there briefly. So Check our meter is working. Yep. This transistor doesn't... Okay, there's a junction there. So we assume then the white lead here is the base. Okay, well, this doesn't seem to be boding well. Let's try it across this way. I think I need to find out the pinouts of this transistor. This transistor looks like it's got one junction. So this transistor to me looks like it's had it. Okay, I'm just going to find out the pinouts of these AF117s. We'll come back and check it again. Okay, skip that. We don't need the pinouts. The reason why it's not testing as a transistor is because the person who's been in here before hasn't cut the screen lead, they cut the base lead. So there is obviously a short on the transistor because I was getting connection, I think, to that pin there, but that is the screen lead. I need to verify that again on another drawing, but that would explain why this poor radio doesn't work. Someone's cut the wrong lead. So what I've got to do now, if this transistor is okay, is still zap it, probably apply a voltage between the screen and the three junctions, but I'm going to have to solder a wire back onto the base connection. Hopefully we can still reuse this transistor. So that's what happens, unfortunately, when someone, I think, goes on the internet and says, oh, I can cut that lead, that's the one in the middle. Just looked in there, seen the first one they've seen, clicked it. No, it hasn't fixed it. And basically what it's done is it's just disconnected the base junction of the transistor and the screen's still connected. So let's, I think we'll try and repair this transistor and see how we get on. Okay, that transistor's out. I'm back in again, should I say. That's TR1, that's the mixer transistor. That's the one that had the wrong connection cut. It looked like they cut the base rather than the screen lead, so it's got no chance of working at all without a base connection. So moving on to the next transistor, unfortunately it looks like he's got around and cut all the base leads of the transistor. So this is the next one here, and you can see exactly the same problem. Looks like he's cut the wrong lead. I need to just verify that, and then what we'll do is we'll cut the screen lead as well, and I'll rejoin the base. If I can do it in situ, that's fine. I think that will do is we'll reconnect all the transistor leads up properly, get rid of the screen leads, power it up, see if we get any life at all. If we get sort of some sign of sort of RF or IF amplification, then we'll go around and start checking various electrolytics. And just for good measure, the last transistor is exactly the same, base has been cut. So let's cut the shield off that one as well, try and resolder the connector back in, the base connection back on, and then we'll try it, see if we get any life at all out of this radio. Right, let's start checking some of these Plessey capacitors. Now these capacitors, you've got to remember, are sort of over 50 years old, and they're Plessey, in theory, should have been good quality capacitors. So this is what, a 10 microfarad at 50 volts, is it? I can't see, I haven't got my glasses on. But, this capacitor here should be at least 10 microfarads, and it should have a sort of like a dissipation factor of 0.05 or something like that. If you look at our bridge here, it's showing at 1 kilohertz, it's showing 7.86 microfarad, and off the range on the dissipation, which basically means that capacitor's dried up. So without question, I'm not even going to bother checking the rest of the capacitors. I might check them at the end, but these capacitors are all had it, and we'll replace those, and then we'll power the radio up, see if we get anything out of it. Okay, let's go through some of these capacitors we've taken out. Let's start with this one here, 12 volt, 100 microfarad. Where are you? And yeah, let's try and go. Let's check some of these capacitors with this LCR meter. I haven't used this thing a lot actually. It's a nice meter, but I tend to use the Packard. So this 100 microfarad at 6 volts. So let's just see what this comes up with. And we're doing this at 1 kilohertz, which is the sort of like standard frequency we do them at. So we've got a capacitance value of, it's reading 131 microfarad at ESR 1.27. So that actually isn't too bad. Okay, that's the first one. Let's check the next one. And this is a 100 microfarad at 12 volt. and that's measuring 22 microfarad with an ESR 34, so that's basically thinks it's a resistor. Next one is a 10 microfarad at 50 volt, and that's come up as 7.8 microfarad at 44 ohms ESR, so high ESR, and it's dropped its value back, so that's basically dried up as well. Another 100 at 12, I seem to use quite a lot of those. That's measuring 22 microfarad at 33 ohms ESR. And the last but not least, a 2 microfarad at 50 volt, 1.5 microfarad at 127 ohms. So yeah, absolutely shot. So I know a lot of people, there's always argument you should always change electrolytics. Generally speaking, when they get to this sort of age, yes, you should. They tend to fail quicker in valve gear because they're under more stress, and they're also heated. They get a lot hotter than they would be in this little transistor radio. But of course, it depends where this transistor radio has been stored. It's been stored on someone's windowsill in the sun for like 30 years. These would have dried up as well, and clearly these ones have had it. So these are caps, and I had it, and so we've replaced all those, and the next step will be to power the little radio up and see if we get any signs now we put these transistors back with their right connections. Okay, it's the moment of truth. So summarise what we've done: replaced the electrolytics that were all had it absolutely dried up. We initially went to replace the screen lead, or cut the screen lead off the transistor and check for screen to junction shorts, and found that actually someone had been in here before. Phantom Dabbler had been in here, had cut the wrong lead, unfortunately cut the base lead and left the screen in position, so basically cutting the transistors totally out of circuit, so the radio was never going to work. So these are 3 RF and IF amplifiers that transistors we've changed, or corrected should I say. The next step will be to power it up and see if it works. So let's switch it on. I've got an external supply plugged into the right here. I'll try it on medium wave first. Well, there's a bit of noise. Not doing a lot at the moment. Long wave. Now that sounds to me like the IF amplifier is working, but the front end transistor isn't, and that's the first one we checked, which is this one down here. Interesting. I think there's something still wrong with that transistor. Let me just see if we get any IF response. Yep. So I'm injecting now 468 kilohertz. The IF amplifier appears to be working, so that's why I like to do this test, just to make sure that I can narrow it down to what the problem is. And it looks like our local oscillator isn't running, and that's this first transistor. Is it that one? Or is it that one? Need to check the circuit. Also, I thought I must have imagined it. That felt like that transistor was warm, which it shouldn't be warm. Shouldn't be the slightest temperature on it. No, I think I'm imagining it. Okay, so we need to work out which is the front end transistor and work out why. Let's turn this off. Why we're not picking up anything. So it's obviously something sort of, it should be fairly straightforward. So we need to check that front end transistor just for wiring again, and have another look. Okay, this is the front end transistor TR1 that I'm suspicious has got the problem. I'm going to replace this transistor because they are leaky. Germanium transistors are leaky anyway, but its collector to emitter junction is leaking about 10k in one direction. I don't think that's right. I think this transistor might have been damaged possibly by tin whiskers. I'm not sure. It doesn't seem to be connected to the any of the junctions connected to the can though. It hasn't done its normal thing of going short circuit between the junctions and the screen, but it is showing some sort of resistance, like a couple of 100k to the screen, which suggests to me that it might have been zapped by someone, but they might have actually tried using the base connection. Obviously they didn't know the difference between the base and the screen. It might have damaged this transistor. So we're going to change this transistor for another AF117, see if we get any better response from the radio. This is an AF117. I found it in my stash of transistors, germanium transistors, but it's got the tin whiskers, of course, so we're going to have to try and zap this one, and let me just show you what you've got to do to make this work. You get it wrong, you'll blow the transistor up, and this is a pretty crude, doesn't always work. I've had quite a lot of success with it, but it's not guaranteed to work. What we're doing now with these two green leads here, these are crocodile clips are joining, they're in a loop, so that all the junctions are shorted together. So the base, the emitter and the collector are all shorted together, and I'm going to apply a voltage between the screen, which is the outer case, and the three junctions, and apply a high voltage across this transistor. And what it should do is blow open the tin whiskers inside. So what the plan is to charge up a fairly small value capacitor to probably, we'll try it at 250 volts first, and then see if the transistor survives that. I mean, this is a 50-50 chance that this transistor won't survive this onslaught, but there's not a lot of help for this transistor other than that, because the transistor's short, and tin whiskers is inside. You can cut the screen, but the tin whiskers are so bad now that they're actually starting to short out the transistor junctions. So let's charge a capacitor up, and then we'll give it the little magic zap. Right, this is the capacitor we're going to use. I'm going to charge it up using the Mega. You can use any high voltage power supply. Obviously you've got to be pretty careful what you're doing here. You're working with high voltage. I mean, a Mega will give you a tingle, but once you put the voltage across the capacitor and the capacitor charges up, there's a little bit more energy there. And trust me, I don't want to be touching this capacitor when it's got 500 volts across it. It won't kill you, but it'll give you a nasty shock. And that's what we're going to give to the transistor instead. So connecting the Mega up now, which is out of view. I'm charging the capacitor now. And what you've got to do, it's difficult to do this one-handed. That beep you hear is the Mega warning me that there's a voltage on the terminals and warning me not to touch anything. So I'm going to reapply the voltage again. And what you do is you hold the Mega down. It's gone to greater than 1 gigaohm. Now, holding the Mega down, you disconnect the test lead. So now that capacitor is charged. So what we do now is we reconnect this capacitor up to the transistor carefully. So we need to disconnect that. Put that out of the way where I'm not going to touch it. So get the junctions back up. So that is a connection that's connected through to these two junctions here. So all our junctions are connected together. This connection here is the screen, if I can get hold of it. It's difficult to see. Okay, now this is our capacitor. I'm going to connect this up to the supply. You should, or you may, see a little spark inside the transistor. So let's zoom in again. This is a bit precarious, this, because I'm doing this one-handed. So watch inside the transistor. You see that flash? So hopefully now those tin whiskers have been blown apart from that transistor, and the transistor's happy. It doesn't always work, so let's get all this disconnected and check the transistor again. Okay, the meter's on diode test. So we're going to go through and do a check on the junctions. So the junctions are quite simple, really. It's basically two diodes. So we're looking for the base connection. So our base connection is the one furthest away from the collector. That's the base. So it's a PNP, so we want the negative lead on the base. We should see a junction here, and we've got a short circuit, unfortunately. Yeah, that transistor did not survive the test. Just making sure that isn't the screen lead I'm using. Yeah, that transistor unfortunately is dead. So I've killed that transistor. It was on its way out anyway. I've just ended its days a little bit quicker. Of course, the other options, we could use some of these. PNP, these are GT322s, which are germanium Russian transistors. And I had a conversation a couple of years ago with Shango 066 about these transistors. He swore that these were much better than the Mullard transistors, and obviously they are. The Mullards are unreliable. He said that he's put these in lots of radios and they work really well. These are equivalent to the AF117. So let's try one of these in place just in case to see if it actually works. It's clearly going to be a more reliable transistor. These are the same sort of era, but they still work. So we'll try one of these transistors in here. I'm guaranteeing it will work. I've got a box of new ones. Look at that, we've even got the pin out. How helpful. Look at that. A nest of new transistors. They look like they're sort of like got a conformal coating on them as well. You see they sort of glint in the light. So let's give these one of these the benefit of the doubt. So we'll connect one of these back up and we'll see if it works. I spent the last hour trying to work out why this radio is not working despite changing the transistor. It looks like the local oscillator wasn't running at all. It's deceptive because it sounds like it's picking up something, but it does sound like it's tuning, and that's I think exactly what it's doing. And I tracked the fault back to the tuning capacitor, funny enough, and I've lifted this wire off here. This is the wire to the local oscillator, and that measured short to ground. Now there is an inductor in parallel with it, but it was actually measuring sort of like 20 milliohms, so it's really was a proper short circuit. And I'm thinking, well, it's got to read sort of like 1 or 2 ohms minimum, I would have thought. Disconnected that. The short goes away on the wire, but the short's still on this tuning capacitor. And there's the tag of the tuning capacitor down there, and that's the ground of the. So that's one side of the capacitor, and that's the other side. So that's the local oscillator. That's the aerial matching capacitor. So I measured across there, dead short circuit. I'm thinking, so what the hell's wrong with this? The fins aren't touching. So I turned it over, and I had fiddled about with this top trimming capacitor before, but what it was, someone's obviously trying to get this radio going, has wound these screws right down, thought they were loose, and there's a Mylar insulator under there. Obviously they punctured it, or maybe just tightened it down too much, shorted the capacitor out, obviously stalled the local oscillator. So I think I've found the problem. So the next thing will be is to reconnect the tuning capacitor back up with these screws backed out, see if we get a local oscillator running. Okay, let's give it a go. So it sounds different from medium wave. Aha, tuning. Okay, it's probably a mile out of alignment now. But we've clearly got something. Turn off phone charger and all the electronics. Right, so let's have a quick tweak. Obviously we've well and truly messed up the alignment, but we've clearly got local oscillator running now. Yeah, see, there you go. There you go, stall the oscillator. That's strange, that long wave seems odd. Shouldn't sound like that. So clearly it's working better than it was. Let's have another mess around with it, but it's obviously the local oscillator is running now because we've got tuning adjustment. and it's probably just alignment now. Right, yeah, okay, I think we've sort of got to the bottom of why this thing wasn't working properly. Obviously the local oscillator wasn't running, and now it is running. So I did a quick sort of rough and ready alignment on the RF front end. So medium wave's working pretty well now.
Obviously, since the Burnley defeat, on a great run, leaving inside the penalty area, there was a penalty.
Could probably do with a bit more tweaking to bring it in line, but long wave doesn't work, and I think long wave doesn't work because of that GT322 transistor I put in. That's the only thing I can really see being the problem after that. It's making noise. It's obviously sort of like this white noise, but this transistor, I've got a funny feeling, isn't happy running so slow as, obviously because that's the local oscillator is being fed into that transistor. That transistor is not happy at running that sort of speed. So I think what I'm going to do is I've got to try and find another AF117 that will go in there. Clearly those GT322s work really well in the medium wave stage, there's no doubt about that, and the performance seems pretty good on medium wave. So I need to find another AF117, we'll reinstate that, and then we'll give it another go and see if we can get the medium wave to work correctly. Right, this is the output of the first transistor that's feeding into the IF amplifier. And you see this is on medium wave, very tuned. You can see that the local oscillator is working perfectly well, no problem at all. Obviously the amplitude drops off a bit when you're at the higher frequency end, but that's fine. The oscillator is working fine, but watch what happens when I turn to long wave. So there's something wrong there, and I think that's the problem. So yeah, we'll try that transistor, see if that fixes the problem, but I don't know why it seems to be sort of like picking noise up all the time. I can't really see what else that can be. There's medium wave, and even with modulation, let's find something with modulation on it. See, no problem at all. Much more stable. I mean, there is noise there, but it's more stable. But long wave, it looks like it's unstable. So let's get another transistor and put that in. I managed to find another AF117, pop that in. It was, funny enough, didn't have any shorts on it at all, so that was unusual for one of those. So let's try it again, see if it still works.
Premier League property.
So medium wave's clearly okay. Now long wave. Oh, that's better. Yep, long wave's working. Excellent. So that's basically the set working properly now. The next stage will be I need to get the front panel off, because I don't know if you can see, if I zoom in on this tuning capacitor, you see it's a little bit loose. And that's basically what the grommets relax over age. I can tighten that up. I need to clean up the dial a bit. It's a bit sort of murky. You have to be very careful when you clean these, but just give this a wipe down. Try and get some of this crud off. I need a bright for this volume control. If anyone has one of those and is willing to donate it for this lovely little radio, I'd appreciate that. Or if they know anywhere where I can get them, I'll buy one. So let's get the front panel off and give the scale a clean up. Right, I've got the grill off, and I'm going to try and push some of these dents out, and actually it's very difficult to see, and at certain angles it looks like there's no dents at all. I think you can see this divot here, there's a slight dent here, and there's a very slight dent here. It comes off as slightly lighter on the camera. There's a slight dent there. Now, I know it's minimal, and most people wouldn't worry about it. There's actually a slight dent just here as well. So what I tend to do is I tend to put it out on the bench, turn it over where it's been dented, so the outside of the grill is on the ground, or is on the bench, and I use a flat bench, and basically all I do is, you can see on the top where the dent is, and you just apply a little bit of pressure and the opposite side just to push it down. Now at the moment it's very difficult to see where it is, and as I say, it's really dependent on the angle that you'd turn the grill at. And now I've actually lost it altogether. I'm trying to find it again. Okay, there's a very slight dent just there. Just apply, don't force it too much, because you can actually reshape the form of the grooves, and that will actually make it look worse than it was before. There's still a bit of a dent there. I'm just going around gently and just sort of pushing. The other thing that I thought might work, I haven't tried it, is one of those old-fashioned sort of rollers they use for rolling wallpaper paste. Maybe that would work. So just trying anyway, just an experiment to just make it a little bit better than it was. Just bring it back round again. And it has improved it slightly, but there's still quite a bit of a dent, just that one there that I can see, which is here. Just the other thing to do is just very gently just try and push it like that. But you don't want to go over the top, otherwise it will look. It's amazing how you can suddenly make the thing look worse than it ever was. Just there, sort of. So I can just almost like bend it slightly. It's very difficult for you to see. It's less. It is definitely less. There's a little tiny one there that's hardly noticeable. It is better, and it's easy to get carried away with this. But you have to be very careful. And unfortunately, I think the first couple of times I've done it, I've made it actually worse than it was. So far, it looks okay. I'm just going to try and bend that one slightly, very slightly though. Just a little bit of a dink there. Oh, that's better. So yeah, you have to be very careful, you have to be very patient with it, and just don't overdo it. It's coming out, there's a little bit more there. Okay, starting to go the other way now, so you have to be a little bit careful. Alright, so basically I think the grille's in pretty nice condition. I think we'll put the set back together again, and then we need to give it a bit of a clean up, get all this dust out of here. I think we just wipe that out with a damp cloth, and then we'll blow it out with an air line, and we'll start to reassemble it. Right, it's all back together again. Yeah, the grill does look better actually. Those dents are not, you can't see them at all now. They're very, very minor dents. I mean, you had to look very hard to see them. Cleaned the front panel up, the dial up. Funny enough, you know, I was saying about how easy it is to take the paint off. I took the paint off, but luckily it was right in this corner, and it's obscured by the bezel of the chassis, so that's good. Yeah, we need another finial for that, and possibly for that one as well, because it's got a dent in it. But the cabinet's in nice condition. Inside, yep, I've cleaned it up and got rid of all the dust and things. It just needs a PP9 battery to be installed, and that's easy enough to get. I can get those. You can still buy those actually, because they're still used in the actual Robert's Revival sets, so that's good. So electrically, we've recapped it. We cleared the short on the local oscillator that was caused by someone screwing the local oscillator trimmer capacitor right down and shorting the oscillator out. It took a while to find that actually. We've also tightened up the tuning capacitor because that was a bit wobbly. We've taken out the speaker connection that was on the back, and I'm going to try and plug that with something. I'm not sure what I'm going to do at the moment, but I want to finalise that. I might put the old plug back in and just leave it disconnected for the time being. So the transistors have been repaired. The person who owned it before, tried to repair it before, had cut the base of the transistors rather than the screen, which is a bit of a shame really, because he obviously wanted to get it to work and cut the wrong transistor legs. So we cut the screens out, and we've resoldered the base leads back on, so that's given us performance back again. We did a quick check on the IF amplifier. It looked like it was working well, so I haven't adjusted anything on the IF, and we've just done a quick RF alignment, and I'll quickly run through this because it's pretty straightforward and I explain what I do. You set the low frequency oscillation, so that like the 550 kilohertz with the signal generator, and you adjust the local oscillator coil here so it reads correctly on the scale. you run up to the high frequency end and you feed 1500 kilohertz in or something like that. I don't know what the manual says, but it's the high end frequency. And you adjust the local oscillator so it's on the right position in the scale, and then you just adjust the aerial trimmer capacitor, which is that one there, to bring the or vice versa, to bring the maximum gain in on the top end of the scale. They're very, very straightforward. And then you set it to long wave, and normally you set on the long wave, you set it to the low end of the one range. I think it's the low frequency, and adjust one capacitor and then high frequency and do the other. But as there's only one transmission worth listening to on radio 4, all I do is I tune it to radio 4 and I adjust these two capacitors to get the maximum amount of gain. Very straightforward. So yeah, that's nice actually. Nice little radio. It's in nice condition. Unusually the handle is still in pretty good nick. Might try and repaint this with silver, I'm not sure yet, but yeah, it's clearly in a nice condition radio. I hope you enjoyed watching this video, and more to come.